Hey everyone, it's George, New Spirituality. Welcome back. And today I am very excited to be sharing with you the research and work I've been working on maybe the past 2 or 3 weeks. I've been posting a lot of images on Facebook of the things I've been working on. And just to give you a sense of where we're going in this is a real awesome form that I posted a picture of the other day that really got me going. To explore a lot of geometries that are contained within this. It's quite a massive structure, and I'm pretty excited to share about this. And I can intuitively just started creating this, and it contained all the forms, many of the forms right within this. So I'll be showing you a lot of the forms with that, and then I figured out the mathematics of it, so I can create them to the right proportions, and this is the inner portion of this form over here, which is the outside. So I'm going to be showing you kind of the backdrop of the things that I've been working on and how I got to those, because I'm pretty excited about them. They're pretty new to me, and I found a few similar things out there, and I'll explore those too. So, this is going to be a really awesome deep dive into sacred geometry like never seen before, at least that I've encountered. It's going to cover a lot of material. And like normally, we'll start off with the screen share and take it from there. So I've set up a really awesome presentation for everyone. And okay, this is it here. So we're going to start off with kind of one of the last slides, but I'm going to keep everybody a little bit in suspense about exactly what they are looking at in this picture. But I wanted to let you know where this is all headed. It's going to revisit a lot of Leonardo da Vinci's work. It's going to revisit the Earth and the Moon proportions. It's going to look at it at multiple scales. It's going to tie a lot of things together. And this is what this form has really allowed me to just expand my knowledge base in sacred geometry 100-fold. So, okay, this is where we're going. So if you want to check this out, just stay with me. I'll probably do a shorter, condensed version of this just to kind of get to the main points. But this is going to really be the main heart of the presentation here. And let me zoom the slide out here. Got to make it to 10%, just to show you how massive, oh, that went to 100, how massive of a project this has been. So we're looking at, I don't know, 60 or so different types of geometric shapes on here, the Platonic solids, Archimedean solids, that new form that I've been working with is on here as well. And so we're going to walk through how all these forms are related, meaning that they all interlink on their internal geometry, which is really just fantastic and neat. And I'm going to show you exactly how they all fit together. And I think I've devised a pretty good way to reconstruct that for you without just lumping one form on top of the other. Now, one thing here that I want to show you is this black line here is dividing the screen into two portions here. The left-hand side of the screen is the form for one view, okay? So that would be, let's say, with this form right here, that's looking at it as if you were looking at it with this square view like this. You're going to look at all these pictures on the left like that. And all the other ones are typically how you would see it in the flower of life arrangement with the triangular or hexagonal shape of the outline of this form here as a hexagon. That's going to be the other view. So I decided to make all these forms in both views to see how they relate to one another, how they look from both angles. So this side over here is all the flower of life, hexagonal type of view. And this side all on the left is more of the up and down side profile type of view here. So it took me a while to figure out the best way to show you all these forms and how they link together. And I think I've come up with a pretty decent way here. Whoops. Let me go back to that slide. And I'll have to zoom in just a little bit here. Make it 15%. Okay, so now this is the new form. This is what it's based on. And I wrote about it a little bit in one of the posts. But I had a visualization around a pyramid, the 51.5 degree pyramid, and viewing it as if it were shaped like an octahedron, which would mean it, instead of having 4 sides up the top, it would also have 4 sides at the bottom to have 8 sides total. And what I decided to do was turn that pyramid on its side and then put it together like this here. Okay, so now you have 2 sticking out to the side, 1 up and down, and then I'm going to put this one, which let's just say this one is pointing right towards you, and the other point is going out of the back, and that constructed this form right over here. And that created the base structure with that 51.5 degree cubical form to make the basis for this form here, which I'm going to call the Pyrahedron, for the pyramid and the shape, okay, the Pyrahedron. So that has, the Pyrahedron here has 32 faces, and I did the same thing here on the left-hand side, is composed, on the other side, composed this compound of the 3 pyramids facing those directions. This is what it looked like. I know it's a little harder to visualize. It gets a little more messy in there than this view, but this created this other view over here. So these are the 2 views, and this shape is going to be kind of the backbone structure of the whole thing. So if we're starting out at the base, let's start at the top. This is where we're going from this point. This is your smallest unit that we're going to work with, building that up as we go, with this pyramid being the root foundation of the whole thing. So here we are with the Pyrahedron, and I know I've put a lot of these on either side here, and that's for a reason. I'll show you why in a moment. But we're going to go through each of the forms as we build and go along. So right now we're looking at the cube octahedron. Now that is a truncated cube, and also an octahedron could be off of this top spot here, but this is what Buckminster Fuller in this view. Let me explode this view for you. So he felt, and after doing all this research, that when you get down to this center point, this is all made of, meaning the inner length here is the same as it is on the outer length here. So he calls it the vector equilibrium. It's pretty much the smallest little dot you can get to that everything is built off of, and that is at the center of this Pyrahedron. So if we take that cube octahedron and we bring it up, see, that's going to fit into the outer shape, and those slopes on this Pyrahedron shape are also sloped just like that here. Okay, so that's 1, 2, 3, and 4 with that square on its side like that in the middle. So that's the cube octahedron from that view. And of course, this is on this side, and we can bring that right up into there as well. Now, the thing that makes it different, that the cube octahedron compared to the Perihedron here, is that it has a little raised section that's coming out. And that little spot that we're looking at that kind of poofs up at the top here, that is the pyramid sticking up on all those 6 directions, right? Sticking out of the top. So it creates that little inflated spot. Well, so now we have the cube octahedron with this little raised spot in it. But that raised spot is going to be very important as we go on. You'll see why it's so important, that the Pyrahedron is actually part of the creation of the cube octahedron, meaning the 2 are linked. And this is the inside of those planes, right? Because we have squares that are the base of the pyramids, one going this way. So we have a plane going like this. We got a plane going like this and a plane going this way, right? So an X, Y, Z and axis. And when we bring those into the cube octahedron, those are going to create the same outer points to create the cube octahedron shape. Now that is the pyramid bases that did that. And now the only difference is that that is going to have the pyramid tip raising out these central locations, okay? So the cube octahedron and this pyrahedron are two ways about getting the same thing, but with the pyramid, we're going to be able to do a lot more constructive building. See, in the past, pretty much the cube octahedron build, you know, you build the cube octahedron and then you take the star tetrahedron, which makes it now starting to be building out to a cube, right? So these are going to join together like this. And then this is just your basic cube, your six-sided cube, like a regular die. And that then encases the cube fully like that. So remember, inside this Perihedron here, the 32-sided face is that cube in the middle there. Okay, and then we've got those little raised spots coming off the sides. So let's go on a little bit further to the next slide. So from that build of the cube, which is, remember, is this Perihedron shape, we're going to build an octahedron onto it, just like that. And surprisingly, this same shape here, when we put it together with this one, it actually mirrors it one for one. So it's hard to tell that they're both in there. So this is called the compound of the cube in octahedron. And this is what it looks like in this view. And in this view, it looks like this over here. Now, the strange thing is when you turn that up on its side, it looks drastically taller, right? So that little pyramid-shaped piece of the tip of the octahedron shape, when you turn it upright, it really gets a lot larger in this view over here. So when we come down here, let me move this down, just so you can get another view of what that shape looks like, because I know it's hard to visualize either from one view. This is another view that I took off of a Wikipedia site. It shows you that from a slightly little angle, so you could see that there's diffusion of this cube along with this octahedron shape, all right? Now, when those two are fused like that, this is the cube that we were working with. And remember, that one fit into this one here. And now we're going to fuse that with the octahedron. So now we have that one fitting like this, right? So where's the tip of that going? Well, if we go up a few versions of this, we'll see that the tips of the octahedron shape will now fit inside the perihedron. So now that cube is down within that. And essentially, that is what is going on in this massive structure here again. If you were to be able to sit and look at this closely and not get all caught up on all the wiggly lines and everything that are going on here, you would see that the cube and the octahedron are growing in that case around this shape of the perihedron. So the octahedron shape that's in there, this long tip here, is now meeting the larger one of this. But at this version of the perihedron, whoops, at this version of it, it is just meeting right here like this and going up and outside. So these now, as you could see, are all going to fit together as well too. It's a real unifying shape. It's pretty phenomenal in my view. And we're going to show you a lot more of what it does as we go on. But I want to get through all these shapes because there's, like I said, this is a sacred geometry like never seen before, because you can see how all these shapes fit and link and grow off together. So when we take these vertices, the cube and the tip of the octahedron, and we build those out together like this, we get what is called the rhombic dodecahedron, okay? So that's the inverse version, I'll put it over here. The dual, it's called, of the cube octahedron, and that shape is just like that. So you see the points hit here like this, and that creates this diamond shape. Now, from looking at this in a 2D view like this, you would think this was just a square with segmented halfway and drawing another X in the middle of it. But this is a three-dimensional shape. And once again, that whole shape of the rhombic dodecahedron fits right into the root Pyrahedron shape. Now, the rhombic dodecahedron in this view, as you could see, will also fit over top of this one here. And so you see how these fit into this one. The rhombic dodecahedron is now what is pointing up, lifting up those little raised points of the perihedron. Those little corners are fitting right at these nodes right here. But if we took the regular cube and put it into this, that's going to go right into this one here, just like this. So you could kind of see, actually the cube would fit in and around this one. Remember, it's the cube, but it's now the, yeah, scratch that one over here, was this one. This is the cube octahedron shape that's in there. And maybe I'll show you, just zoom in real quick. So if you see that this cube here, if we cut off this side of the cube, we would have the octahedron shape within this. Okay, but the perihedron is that little point is the pyramid sticking up out of the top of the cube. So these forms are all linked together like that. Now, as we go a little bit further, let's go back to the basic cube. We've just taken a step back and we're going to look at another build out now. And this is going to build up to this Tetraxus hexahedron. I posted on this or did a video on it maybe a few months ago, maybe my 5th or 6th video. It might have been within the Christ consciousness grid video that I did. So, you know, I always wondered about how that octahedron that creates the Tetraxus hexahedron, where did that come from, right? How did that just step into place? Because we could build that out. And if we take these, this is the tris octahedron, right? So now this is a smaller octahedron than we had before. The other one created that compound, which meant that that edge of the octahedron met right on the outside of the cube. But this one has a smaller octahedron in there. And I made a bunch of these. This was the tris octahedron that I found the name of. I was calling it the soul, I am calling it the soul star. I'll still call it that. We're looking at it from this view in this picture, and from the other view, we're looking at it like this, okay? And from this view, there's a, you know, back then I knew there was an octahedron in there, and it knew it was related to the pyramid. So when we, that's this shape right here, okay? So that's like a star tetrahedron in the middle of that, but it also is now inflated out because it has that octahedron in the middle. And that actually fits right into this one here like this, okay? So now I've shown you this one, and this one all have parts of this build, okay? So this one is here, and if we drag it down to this one, the tris octahedron, it's going to meet, not at the top, but it's going to touch here at the top of the cube now that is in this one, or the octahedron that is in this, or the cube octahedron that is in this one. All right, so I know I'm throwing these words around, and you might have to like watch this video again if you're really into this, or I'll be writing, probably going to turn this all into a book of some sort, or some sort of pamphlet that I can put out and really write and describe these things, but I'm just so excited to go through all this now that I'll show you it this way, and then I'll elaborate on it much more. So just bear with me and go along. But here's the Tetraxus hexahedron, and that is the 24 sides, okay? And that now has that octahedron in the middle, and it has a cube at the base, right? Cube in the middle. And it has that little raised spot, and it's raised because that octahedron is pushing up on it. But essentially, it is also fitting into this root shape here, right? So it pushes up on that one. The cube itself is the size of this one, and then it has the perihedron down in the middle, or it could fit all the way down into this one, and it fits perfectly within the octahedron shape. Within the square shape, the cube octahedron shape of this one. So that's why I'm saying that this form is pulling both of these splits to go, because this is going to build out a different form than the rhombic dodecahedron, which is where we ended in this one. We ended here with the rhombic dodecahedron. In this form, we're going to end somewhere else, but those two you're going to see are related too. So this is the view. This is the more star-like view, and this fits together with this one. That's the octahedron that's pushing it out. And when we put that together with this, it's going to create the cube with the Tetraxus hexahedron. So that fits there. Now that's got those little raised spots right here and here. And essentially, that is because those spots are going to relate to right here. They're either pushing up those spots in this one, or they're back over at this view where it has the raised spot that's a little higher than the perihedron shape in there. So there's really no one view that the perihedron here will show up at. It's kind of mixing back and forth between all of them and kind of tying them all together. Now, we're going to go even further into this and go into when we're building with the Tetraxus hexahedron. I'm going to show you how that builds out. And I did this previously in the video that was on the Unity consciousness grid, the Christ consciousness grid, which is this form right here, the rhombic tricontrahedron. So when we build this out, what we're going to be doing is we're going to be building the dodecahedron, which is the 12-sided figure. Let's get closer because there's a few key spots to show. So this dodecahedron fits right on the Tetraxus hexahedron, and it does so in a very specific way, meaning that the point here fits on the top bar of the dodecahedron, which is right here in the middle. So when I bring this up, and the back edge of the corner of the cube fits in the back corner of the dodecahedron, that bar that goes across here on the edge of the dodecahedron mates right at the pinnacle of those locations there. All right, so it's dividing that bar in half. And you would have to have 5 of these cubes twisted around to create the full build out for each of those bars to be touching. But for this is simple enough right now to see it this way. So that's how the dodecahedron is built off of the Tetraxus hexahedron. So the dodecahedron in this view then, you're going to see is either going to be at the top of this where that one met, or it's going to meet right over here where the Tetraxus hexahedron would fit right within that one. So that once again is still built in there. Now, when we join the Tetraxus hexahedron with the dodecahedron, we've got that built out like that. Then we take the icosahedron, which is the 20-sided die. Okay, so this is a Platonic solid. This is a Platonic solid, the dodecahedron. Now, this is what it looks like from this view. When we build that out here, we come across, and that now also meets at the tips of the Tetraxus hexahedron there and builds out to the side here. So we've come up with this compound view. I know it's looking a little chaotic, but in in the end, what you ultimately get is this. When you link all those together, you come up with a highly structured form, which is the rhombic tricontrahedron. And that is what's called the, it's thought to encircle the Earth. You know, a bunch of ley lines run along those points. It's also called the Christ consciousness grid. So that is what the rhombic tricontrahedron looks like. And it's built off of this view coming all the way out to here, and it's contained within this Pyrahedron. At that view and at this view, it comes out the top and encases it like that. Now, in the same view here, I'm on this side and I can do the same thing. And I'll show you later on why these all of a sudden are turned like this. It's because the geometry has to turn like that in order for the dodecahedron to meet up with those points along the cube, like I was mentioning here at the top. So those bars have to come across and segment that. And when you do that, that means that the cube, the dodecahedron, is all of a sudden turned on its side. And then that fits together like this. And then that one, when you join that all together, it comes together like this. And then if you remove a bunch of bars, you'll come up with this 30-sided image here. Now, we could take this view, essentially what this is right here, and keep those faces, and we can create a 60-sided structure here called the deltoidal hexacontrahedron, which is this here, and that has 60 faces on it. So we're really increasing dramatically in our size. And of course, this once again will still all fit within the Pyrahedron. So, you know, I didn't know any of these names. You know, I knew the 5 Platonic solids and some of these other forms, but we're really going to start to go into some new territory with forms that, you know, I still can't remember what these names are. But, you know, a lot of these I found through the drawings that I was doing. And then I'd go back and be like, oh, wow, that's the deltoidal hexacontrahedron. Wow, that has the 60 faces. So, you know, it's a way that I was doing the geometry here was discovering, finding, and then going and researching and discovering a little bit more about it. So it was kind of a huge unveiling to me as I did this, and which made it very exciting to be engaged in the process of discovery, even though many of the things that I was discovering here were already previously discovered. But it just showed that they were all linked together, and I was understanding the reasoning of how this form, this deltoidal hexacontrahedron, why it was looking the way that it was. Because I was understanding the links of the internal geometry, like the whole mystery of it all was being unveiled. So we're going to keep moving forward here. And this one, let me go back out in my view. So we're going to join, this is part of that discovery process was this right here. I was, I said, well, what happens now? Because remember, we took that branch. We had the rhombic dodecahedron back here, which had the bigger octahedron around the outside. And then we took the other view, which was built off of that Tetraxus Hexahedron, which had the smaller octahedron in it, which was this one right over here on the previous slide. This one right here. So let me just copy that and bring that up into here. So you can see the difference in the size between these two outer octahedrons, right? Because one built the Tetraxus hexahedron and the other built the rhombic dodecahedron. So, you know, I was like, how are those two related? So what happens if I take the rhombic tricontrahedron that I just built, was showing it was built off that Tetraxus hexahedron, which is built off of this octahedron here, and combine it with the rhombic dodecahedron. So, you know, that when I did that, you know, this was like, I was like, I have no idea what I'm going to get. So I put them together like that. And then I spent quite a while trying to figure out what new form has just been created, because this is a raised ridge now. It's going to cover up some of these other areas. And I had, I had the forms in my hands that I have built here. I'm looking at them from different angles. I'm trying to figure out which lines connect. And eventually I come up with this, right? And this over here from this view. And that was a real puzzle to figure out, because it's built like this wild swirl looking to it. And it actually works. And it is something, because it's right here. I didn't know it at the time, but I made this Diaxis Dodecahedron. And this form is huge in crystallography. Like, I stumbled upon a site yesterday that has hundreds and hundreds of pictures of all these forms. Basically, everything that I did, after I looked through it, I was like, wow, I've just been studying crystallography of every mineral that we know created out of all these structures, octahedrons, cube octahedrons, rhombic dodecahedrons, and this one specifically, the Diaxis Dodecahedron. When you raise these together, when you put these together, you wind up getting this shape here, which is the fusion of this tricontrahedron, rhombic tricontrahedron, and the rhombic dodecahedron joined together, comes up with this Diaxis Dodecahedron, which still has all these root shapes of all the squares in it built up all the way until it fits still all snugly within this. And this view here, I know it's a weird one to look at. This is much more uniform and easy to look at. But we, interestingly, I had this juggling ball here. I have 8 or so juggling balls like this shape. And I've had this for 10 years. And when I looked at it, I said, wow, I can't believe it. This is the shape that I just created. Here it is. There's the 2 going down. If we continued that line across, and we have the 2 coming in from the side, the one that goes over the top, the one at the bottom, and the one on the side. So that's this one wrapping around, this one wrapping around the top, and this one wrapping around the bottom. They basically took this Diaxis Dodecahedron shape and turned it into this juggling ball spherical form. And these are really nice juggling balls, nice weight and everything too. Now, the cool thing is like, I know this has got these 3 different size shapes here, and they kind of create this twisted swirling pattern. Well, when I took the juggling ball and I put it like that, you see the way that it has that kind of twisted shape here. It kind of looks like it's in a corkscrew type of motion. Essentially, that's this Diaxis Dodecahedron. And, I was like, wow, I can't believe it. It's like a new form all of a sudden to me, because this, wasn't on my radar at all. But the only way I found it was because I combined these 2 images together. So, okay, that's one point. We're going to keep going from there. So, now we have the Diaxis Dodecahedron. And from there, we're going to take 5 octahedrons, compound of 5 octahedrons all joined together. And when you do that, you get this shape right here. It's called the compound of 5 octahedrons. It's a 40-sided face. And this is an important shape to help build out to where we're headed. But when we place this over top of the form ahead of it, we'll see that it kind of raises everything and makes it a lot bigger. It makes these pentagonal faces, and these little points here are now going to be encased within these triangles that are kind of underneath it, touching the inner edges of those triangles right there. So let me just come in here and make a better zoom in a little bit. See the points of those? They're touching on the inside of those triangles. So there's that contact still between the 2 forms, even though this one just got a little bit bigger. And everything now from this point is going to be pretty much fitting within this largest view here. The same thing with this one. When we come up to here, you'll see that those tips of those points right there are raised up, and they're touching the inner portions of those triangles on those spots. And now that form is kind of wrapping around the Diaxis Dodecahedron. So, I had no idea, I had no idea that I would be going out to like 40 or 60 sided images, 60 sided forms in this exploration. And it just kind of literally like snowballed on itself. Once I found the kind of key of how these things all kind of link together, and especially because of this form here, it all just started to build on itself, quite easily. So, when we take the compound of the 5-octahedron, and then we take the icosahedron from this view, and we place it in there, that's going to then raise up and push out that center pentagon that we see in here. So that little point comes out of the white pentagon shape. And when we take that and put that together with this one, we get the Pentaxus Icosa Dodecahedron, just like that. So you can see, let's get a little closer again. You'll see that this has a raised face. Originally, we take the icosahedron out there. It just had this flat face like this. All right, but now we've got this raised section right there because of the icosahedron making that, poking its way out there. Same thing with this view over here. And so that's this Pentaxus 80-sided shape. And, I was like, well, what happens if you raise some of these triangles here? What's going to happen? What will be the next thing that happens after that? Okay, so this is the geometric shape I took from online. This is what it's looking like on the 2D. And of course, this thing is still fitting all within the large shape here. And you can see as I'm evolving through these slides here, how they're all linked back to the original cube that we started with, this original shape back here with the Pyrahedron back there. So yeah, when we take the Pentaxus Icosa Dodecahedron, okay, I was like, all right, so we're gonna raise those shapes out, and we're gonna take a dodecahedron, which has got 20 vertices that make it up. So the vertices are the little points that are raising out here. And if we bring that up into this, it's going to raise out the equilateral triangles that are part of this. So every equilateral triangle is going to get a raised projection from this dodecahedron that gets placed inside of it. See right here in the middle? I'll go in again a little closer. Right, so that one's raised out, that one gets raised out because we just inflated that dodecahedron, made it a little bit bigger than before, placed it right in there. So now we're getting the a little point poking through, and now that gives us a way to connect this edge to this edge, to that edge, to that edge, to all these different edges now that we've got on this. And that gets us, that shape, in fact, is called the Tripentacus Icosa Dodecahedron. And what the image that they showed that did that was, they just took a little short 3-sided little tetrahedron, small one, and put it on each of those 20 faces. But I figured out that if you just do the dodecahedron inside, because I wanted to stay connected to geometric shapes underlying the inflation here that we're seeing, I kept looking for the forms that we're doing it rather than just adding, little caps to it. And when we do that, we come up with the big one. This is the biggest, this is as far as you can get that I'm aware of with sided faces, other than there's a few other types of forms out there, but following this geometry, we've got 120-sided Diaxis tricontrahedron, 120, and all of those points along there are going to line up because of the 80-sided form, including the dodecahedron that just got placed through it, just like that. So, they made, a few months ago, I bought this gigantic 120-sided die. I like collecting different types of die. Here's the 60-sider, here's the 120. It's giant. Look at it compared to the cube or to the dodecahedron here, right? That's a normal playing die dodecahedron. This is the gigantic 120. Diaxis Dodecahedron. So it's 120-sided faces, and that's essentially what this created and came out to by following from the beginning and from this Tetraxus, the Pyrahedron shape. And of course that now, because it's sharing those points here, are going to line up, those little white dots are going to hit the corners where that original octahedron shape had touched through. That first big octahedron is still part of this root foundation of this build out. And this is just what this view looks like. This Diaxis tricontrahedron. This is how they did the little raised peaks over top of these faces to get another plane. And this will then fit over top of that like that. And that's more of a view of what that looks like. And this is that view from the side. And I found working with this view here on the left a lot easier. It was way more intuitive for me to do it than through the traditional flower of life. I'll show you why the flower of life, when you build it out to the fruit of life and even extend it even further, why it didn't really work out with building these forms, because you start to have things that are angled like this, and then none of the points, when you angle them, when you want to keep them all together, they don't link up in the flower of life. You can continue to build these forms out and build the star tetrahedrons and build the vector equilibriums and build all that stuff. And you can draw the dodecahedron in there, but to actually show how the dodecahedron connects to those, it had to be angled like this, and that breaks the geometry of that. And I'll show you that in just a moment, a little bit in a few slides later. So there's one more form here that I want to show that took a while to figure out, and it's a 48-sided structure called the Diaxis Dodecahedron. And I really like this one because it's got a very similar look to the Perihedron shape. Now we take that compound of the octahedron and the cube and we join those two together. Remember, that's this shape up here. It's a cube and an octahedron fused together. And we're going to now take that and we're going to go for a bigger cube octahedron than the one we had before. Now the cube octahedron we started with was just this big right here in the beginning. And now we're going to expand that all the way up to this size cube octahedron. Once again, this Perihedron shape is still found within it. All these views here on the left and right are connected. So when we join these two together with that big cube octahedron, with the smaller one, with the big octahedron cube compound with the cube octahedron, I know it's a mouthful, but here then we come out and then we're able to get all the points for the Diaxis Dodecahedron. And this was a real brain burner to figure out how these joined up, because we had to have the smaller cube touch these vertices, right? So that was from the cube pressing those out, but then we needed the octahedron shape to press out these, and we needed the octahedron on the outside to get these vertices. So that gave us the 48 in total when we were all said and done. It's a really cool shape, and it's very similar in look. In fact, when I first created this Pyrahedron shape, I came across pictures of this and was like, wow, that's very similar to that. Is that that? But I couldn't figure out why these were not inflated out on this. Because the Pyrahedron, the shape that I was working with and designed here, only really, it has the flattened cube octahedron here. It didn't have the cube on the inside. And the reason it took me a while to figure this out is I had to realize that I was looking at two different things here, and I needed to actually turn this like this. And when I figured that out, then it all clicked, because the octahedron is what raised that shape, right? Because remember, this shape has the octahedron at the top. This orange one here is the point of that. And that octahedron is the same as this one. So remember, that's going to go back and fit into, whoop, not that one, one of these. Yeah. Yeah, this one will fit into, get it straightened up. Fits closely into that one. There we go. It fits into that one like that. And that was the thing, that was the kind of big stumbling block that I ran across when I was creating that one. I was just really confused, couldn't figure it out, but then realized that the octahedron had to be this one. It fit right into this one like that. See the octahedron, the cube, and then we turn this one to the side. And that will match up with this one right here like this. And then that's the Diaxis Dodecahedron. So now we're going to move, those are primarily the main forms that I worked with. It was quite a lot, but it took you all the way from this form, and even a six-sided little cube, all the way up to 120 faces. And this is something that Buckminster Fuller was doing here, this next component that I saw some images of his drawings, of what he called the 31 great circles, where he took actually this Diaxis tricontrahedron, and he connected it with the Diaxis dodecahedron, which was this one that I was just showing you. I've turned it back the other direction. So those would join together like that. And then he did something with this dodecahedron to get a few more points on there. I didn't work with the dodecahedron, not yet at least. But I've got this Pyrahedron, which I realized also, I've turned that on its angle now. We're used to seeing it the other way. But because this one got turned, I turned this one. So that has 7 great circles. So I said, hey, what the heck? I'll join my 15 and 9 and 7 great circles together, and I'll join and I'll make this. So that created 31 great circles also, right? So we got 31 great circles, and the cool thing is when we take it and we place it, the whole thing fits right back inside the basic Pyrahedron shape, all those spherical forms, right? So this one here, which when we lay that over this, it fits right over top of all those points, all those curved lines which go around in the back. Same thing for the other ones. And then we've got 31 great circles with the Pyrahedron. Now, I don't know if it's actually 31 because, some of these lines are going to overlap one another. But, it's some 21 or something like that. Let me zoom in here so we can take a close-up look at this. And, the cool thing I think I'm reiterating here is that the Pyrahedron shape, this massive structure, which is built off of many expansions, essentially, we could take this same 31 great circle shape here that I have here and condense it and pack it all down and put it into the smallest cube, right? Because we have basically a big cube here that I've put this around. Or we could extend it out now further and fit it into that shape, a larger cube. So this spherical structure is going to be at any scale, like an atom, small atom, at like the size of like a planet or something like that. Okay, so last night I was, I kept doing more research. I put a lot of effort in before I created this video because, I wanted to deliver something here that made sense, that fit together, and that kind of closed as many doors as I could behind me with not leaving too many giant holes. And I just really needed to find and discover a little bit more about what is this shape here, this one that I was working with. I haven't seen it anywhere, the thing I made out of straw here. And I typed in Pyrahedron into a search just to see what would be for the Pyrahedron. I'd be like, Pyrahedron, that's a cool name. Maybe I'll call it Pyrahedron because it has all those pyramids on the inside, right? It's this giant thing here, the Pyrahedron. So I said Pyrahedron, and then all of a sudden it sent me to this crystal site, which had 1,000 images of all these minerals and all the structures. I mean, I felt like it was like, a big unveiling to me, at least, after doing all this work, how much is known about all these structures at the subatomic level, at the atomic level. All these are part of crystals, part of minerals. At every scale, these are probably found at. So, I typed that in, Pyrahedron, and then I came across something in that search called the Escher's solid, MC Escher solid. He's the one who does all the cool staircase designs, but he did phenomenal sacred geometry as I was doing some research on him. So let me share the screen here. And I came across Escher's solid. And Escher's solid is essentially this image here with the chameleons in it. That is Escher's solid. And Escher's solid is a compound of, just like I created, just like this. It has the planes, one square plane like this, one like this, one like that. It's part of this little toy that I bought my son last Christmas. Like, at least I said it was for him. It's part of this structure here. It's got the plane like this, up and down, and this one here, except it ends here. And that's Escher's solid. And these could all fit together. In his drawings, he also created the pyramid structures that poke through the top, just like I was doing. I don't know if he used 51.5 degree angles like I did and fit it into all the other geometries that I just sent you. But MC Escher, these are both of his drawings. Study for Stars here. This one's not what this one is called here. He's drawing that because he probably did many of the same explorations I did. Here's the Rhombic Dodecahedron, Icosahedron, Tetrahedron. Here's that cube compound with the octahedron. Star tetrahedron, dodecahedron. This is two cubes joined together like that. Here it is here, all these other forms floating around in the background. So, basically my visualization that I did was built around the 51 degree pyramid, and I was able to find that it was linked to all those other geometries. Here, I don't know if that's a 51 degree pyramid. It might have been a regular octahedron, or it might have just ended, as in this case, to the top here and just created a kind of square structure. And when you link these spots together, it creates a regular cube octahedron. So it's very similar to the Pyrahedron shape, but the Pyrahedron, because it built off of the 51.5 degree angle in the middle, creates that structure that looks like this, that we were building with. And you've been looking at it kind of like this the whole time in those images. So now on the crystallography site, I looked through probably a few hundred 400, I don't know, a lot of slides for all sorts of different minerals, and they have beautiful structures. And I went through all of them like, oh my gosh, I can't find anything on the Pyrahedron. So they had this one little section called Other. So I went to Other, and then I finally found something that looked like the structure that I had worked on in this example. Here's an example of pyrite that created that. And pyrite, here's a little chunk of pyrite, and I could tell why pyrite would do it, because pyrite grows in perfect cubes. This is a chunk of pyrite. It grows in a perfect cube. Really neat. I'll show that on the large screen in just a moment. But here's the octahedron faces. I mean, the cube octahedron, 2, 2, and 2. And then here are these little 1 faces. That's where the octahedron, or the pyramid shape, pokes through those faces there like that. Here it is in this view again. The 1 has the 4 broken up, and the 2 like that. And that was really the only spot on the whole site that I was able to find something that looks similar. So maybe there's something more that we'll discover with this shape. Maybe there's something more we'll discover with the shape in related to some unknown factor. I feel it links a lot of things together, maybe some other atomic structure. I don't know, but I'm going to keep following up on it and looking into it myself. And I know that there's something specific about the 51.5 degree pyramid and why it's so important to that structure and to the spiritual concepts and the ascension spirituality components, which we haven't touched upon as much here in this video. But here is that Escher solid, right? Looking like that. And the neat thing about that is you could make that back into a cube like that. So this one is, Escher solid essentially, but it has the raised, let me get the right view. There we go. Here's the Escher solid view, but there's the pyramid peeking out of the top like that, and that went around and created this structure here. And pyrite, here's the cubical structure. Pyrite, amazingly, just grows and comes out like this. It's not shaped into a cube like this at all. And that is, contains all these root forms. If I look through that crystal site of pyrite, rhombic dodecahedron, the octahedrons, cube octahedrons, even the form that I'm showing you here today, the Pyrahedron, just like that. Okay, so, that was a big, big deep dive into all that sacred geometry, which expanded out the Buckminster Fuller size things to the pyramids. I know I'm going to keep going with this video. I said I'll make a shorter one, but I want to get the whole thing done, include it all in one. So I do have a few more slides to kind of wrap this all up. Okay, so that was as much as I could find on that shape. And this is where I started. So I said, hang with me. I hope you found all the other material quite interesting. Let's view into the original DaVinci's Vitruvian man. Zoom in 30%. All right, that'll work. So, I pared this down a lot because I started taking all the shapes of the Pyrahedrons. And a while ago, I was working on one of the previous videos, I believe it is the Sacred Geometries Map to Christ Consciousness or something like that. I started mapping this out on here because there's a couple phi ratios in these cubes to circle and square. So the sacred geometry, like one of the key things is to create a circle that has same area as or same perimeter as the square, which would have equal areas as well. So we have this circle to square, right? And square representing the matter, the circle representing the spirit. So if both of those are equal, then we have a union between the fusion, which were never separate, between matter and spirit. So, in the linking of those two, circle and square, there's a few different places. If we take a circle and square and build it out with the circle and square on a grid like this, where they'll overlap, meaning that at a 4:5 ratio, 4 here, up 4, well, 8 to 10 basically, that will be the first location where we get a good phi ratio, very close to phi, meaning that it comes up to, the 1.618. When we go up to the next one we get to is between 7 to 9 right here. So there's the circle crossing through the center of the moon, that's 7 to 9. And if we go up a little further, I discovered one way back, like last spring or winter, I came up with, well, what about 11 to 14? That, I'm saying half of it, really it's 22 to 28 proportion, because we have to go 11 up, 11 down, 14 this way and 14 that way. That'd be 11 to 28. So I had all those linked up like this, and I said, well, what happens if I take the Pyrahedron, which I know contains the pyramid, because at the top of each of these these squares here, if you take a pyramid and go from this line up to the top of the circle, the pyramid will fit in there. So I said, okay, well, let's take the Pyrahedrons and put them in there. I actually did it the reverse way. I put all the Pyrahedrons in and then figured this out, but I'll show it to you this way. So there is the first Pyrahedron. Okay, so we have the person in here, and that Pyrahedron is 4 to 5 in this distance here, okay? The next one, if we take it at this view, we're going from the 7 to 8. And that one, this square, fits in around the Earth and goes to the moon. Now, the cool thing about this is that that square of this one, remember, each of these are built up with a smaller square within them. So that square, these squares, whoops. Let me just keep building it out this way. I'll just keep building it this way until we get to the big one. So we got that square that fits around this one. And then when we bring this one down here and place it around the larger one of the Pyrahedron, that's the 11 to 14. And then we've got the square for this one, which, remember, this one contained a square of the smaller square inside, because remember, the octahedron, we did all this in the previous section of the video. That octahedron, that yellow line, and that cube, or that compound of the cube and the octahedron, they match up, and that inner square fits nicely right around the one that encircled the Earth here, all right? So that is how these three kind of link together. And, when we've got the moon here fitting between that square and that square, and then if we put these rest of these in here, we've got this one here, which that one goes to the center of the moon, and then this little one here, that one goes to the center of that view there. So, we could take this person basically and put him at any level, but visually, I felt like having the 3 layers of the Earth, the moon, and the Earth layer, Pyrahedron, built out all the way to the newest one, which I did something drawing like this, calling that like the angelic consciousness or something a little while ago, putting them out. These 3 linked together, all contained within that giant Pyrahedron shape successively. And this 28 by 22, this largest one, the difference between the circumference to the perimeter is the closest to phi you'll get. And they're all linked back together through all these vertices touching all the way back. So that is one way we can kind of look at what DaVinci was working on. And Gianvallo Melchizedek was showing in some of his books, The Flower of Life, Secret of the Flower of Life book. And one other thing that I thought I'd put in here, which I thought was cool in Gianvallo's book, is how he shows that these 8, I'm gonna have to zoom in to show you this one. Take all these off. If we go back to this level, and this was a drawing from DaVinci, the way he did it, and we take these, if we take this circle here that fits in, this little yellow circle, I know it's all yellow, but there's a little one in the middle that's squeezed in between these. I'll even go closer so you can see this. So it's squeezed in between these larger circles here. And then you take these squares, which are built out to the corner of these, and then you take that unit, which is this here, and then that little yellow circle will touch the bottom of this when you place it on this section here. Will touch this blue circle, and this blue circle goes around here, and the yellow circle, the white circle here is actually the squared circle, which goes all the way up around. That touches the black edge of this other one. So there's 2 edges. There's the inner black one and the outer black one. Those link together, and that little layer here, this little membrane between white and blue, when done like this, that DaVinci figured out and written about by Gianvallo Melchizedek, that there is the thickness of the cellular, between the cell. There's a little membrane of wall called the zona placunda, which is fit in between this inner area and the outer area. Has a thin little area, and that's how you find the difference between the two, is with these circles, and it's found within the 4x5 grid or 8x10 grid area. So even though that is just really an aside here, I thought it'd be cool to bring that in just to show you how that works and fits in there and how it connects to this major piece here. Now, a few more pieces, and then I'm getting close to wrapping it up. You know, I wanted to basically take the same Pyrahedron shape and build it all the way out from the beginning, build it out all the way to the 11th square, and see if it would match as we went along in those successive layers, which are basically increments of the phi ratio increasing in size. So we're looking at pyramids, these red ones getting larger and larger and larger. And when we started from the middle and went all the way out, we ended up right at the last circle here. So it feels like to me that this replicating pattern of this big structure that I made is just going to infinitely go on expansively forever, you know, in a phi ratio relationship of some sort of universal structure built around this Pyrahedron, because it contains both that larger octahedron and the smaller octahedron, which are uniting the 2 elements of geometry that I was showing before, how we ended up with the rhombic dodecahedron or the rhombic tricontrahedron. We join those 2 together. Okay, one other piece here that was very cool. You know, when we did the dodecahedron and we had it in this view, I wanted to just illustrate to you that because the cube is now facing flat, that the dodecahedron, you know, if you turned it like the star tetrahedron and had the point up on the cube, that now is actually over to the corner, but it actually, for the Earth, is at a 23.5 degree tilt anyway. So it makes total perfect sense to keep the orientation of the this shape like this, rather than to turn it on its side like in these previous drawings, like this view over here on the right. That's typically how we see the Flower of Life designs, but if we keep it in this view, then we're totally fine, because that corner of the cube is actually at a 23.5 degree angle. So that's that view. And a couple other things I wanted to show you, that when we look at this view from above the Earth, and we put this down on the ley lines at this this vector, forget the specific name of these lines set up. It's the vector equilibrium. Not sure if that's it, but it's something vector. But if we lay those out across here, and we take this shape and place it over, that little cross point that I've been showing you this whole time, of that diamond-shaped cross point, that's at the center point about maybe 50 miles away from the Great Pyramid in Giza, right there, at that point on location. Now the antipode of that, antipode is basically the opposite side of the Earth from it. This is what it looks like opposite of Giza, of the pyramid, Great Pyramid. And here's Stonehenge, right here, built at another one of those cross sections, right at the same place, not the same place, but the same geometric location. Here's Stonehenge, and this is what it looks like at the opposite side of the Stonehenge. And then here is another spot right close to the border of the US, right here in Cubaibi, Sonora, Mexico. I don't hear many people talking about it, but it's right near one of those locations. Maybe people will start checking it out a little bit more. Certainly this mountain looks like it has pyramid-shaped qualities to it. And this is the opposite side here. So a neat thing about this picture that I thought was interesting when I found out directly opposite through using this grid of these locations was that most of them are all water, and all the land masses were up there, almost like there was this flow of energy going up and around, gravitating to one side of where the continents were to this open water area on the bottom side. Just some speculation there to consider. And I'm very close to wrapping this all up. The one last piece I wanted to show you is a while ago, I was talking about this Metatron's cube and Metatron's Tesseract. These were the lines that I created for Metatron's Tesseract. And that's in another video. I never actually got around to showing you what Metatron's Tesseract. I said a while ago in one of the videos, I was going to show you a bunch of forms that it contains. That's a little too close for everybody. So here is the Pyrahedron in the drawing. I'm going to go through these quickly, but these are all going to be out in book fashion at some point. Here's the cube octahedron. Fits right in there. Now, those familiar with Metatron's cube, that starts right here at the fruit of life. What I've done is gone up to the back edge, and that's how I'm doing my drawings from there, because some drawings I wasn't be able to draw. Here's the star tetrahedron, quite easy to draw. Cube, right? Octahedron, the 8-sided shape. Another easy one to draw. There's the cube compound. Rhombic dodecahedron. Here's the trisoctahedron. Now this was the reason why I went out to those outer points, because I was able to get all the points of the trisoctahedron at the time, which was this shape here, which I was calling the soul star. That was this shape. So that's why I went out to that point, and I just started using this as Metatron's Tesseract, because this cube, this hexagon in the middle was the same as the outer ones. So that's why I started using this and called it Metatron's Tesseract. There's the Tetraxus Hexahedron. Also wouldn't be able to draw in Metatron's cube accurately, so I'm using Metatron's Tesseract. Also, the dodecahedron is very easy to draw with the Tesseract here. Quite easy, nice drawing. It was easier to draw, much easier than to do out of Metatron's cube, and more accurate. Same thing with the icosahedron. It's the accurate view of the icosahedron in Metatron's cube. When it's drawn, that line goes straight across here, but because now we have this point on it located, then we're able to draw the icosahedron as it should be drawn three-dimensionally or 2D. And that's the rhombic tricontrahedron. Here's that Diaxis Dodecahedron. Unfortunately, that was not, those points are a little odd to show up in any drawing, so it doesn't fit perfectly, but I put it in there. Deltoid hexaconchahedron, that one's in there. This one, I had to go a little smaller here, but the rest of it, that compound, the 5-octahedron. The 48-sided face, Diaxis Dodecahedron, that fits in there really nicely. All the points are accounted for a 48-sided face, right there in Metatron's Tesseract. The Tetraxus, some of the points were not in there, but could easily be found just outside here. We needed to get those. That was the 80-sided shape. And that was the Diaxis tricontrahedron. Also, some of the points were a little tough to get in there, but they could be found easily enough. So that was Metatron's Tesseract. Many of the forms were in there, not all of the new ones I just found, but very close to almost all of them. And that's the 120-sided shape. So I know this has been full video, and I'm going to elaborate all on this at a future date, many other little pieces to come about, like adding in spirals and things like that. But I wanted to, like I said, group this all together into one larger video, probably an hour and a half long or so, just to give you the full depth of what this form, how much it unlocked for me in this Perihedron shape. I'd love to find out if people know more about it. And I'm very thankful that it was quite a gift to have that expansive creativity flow through that in all the various ways. And I thank you all very much for hanging in there with me. And if you stuck through this video, you just got a really extensive look into sacred geometry, like I feel never seen before, looking at all the shapes and looking at it as connected to DaVinci's work, some of Dronvallo's work, connecting to different locations on the earth, the sacred sites. This essentially, what the Pyrahedron is telling me is that everything is created in that pyramid shape, and part of that 51.5 degree angle. Pyramid has always been a view as a sacred spot, sacred place. People were building pyramids on the earth thousands of years. It's a sacred temple. We are living in a temple. Earth is a temple. We ourselves, our bodies are temple. We're all temples of God. The one thing that I forgot to put on here was, even on our dollar bill, they have the pyramid with the eye of God. In God we trust. So all of it is relating to this temple building, treating ourselves and one another as temples of God. And that is essentially what the Pyrahedron is teaching me. And I did a little research on the Pyrahedron name that I came up with. And I was just typing in, well, what's Pyrrha stand for? Where does it come from? Well, there's two views. One is both related to Greek. In Greek, it says it either means fire, fire in the middle, and like the ascension chamber, fire in the middle. The other view in the Greek, the other translation of it, was a wheat cake, like a little cake of wheat. So either way, I love the two perspectives. It's either this awesome fiery ascension process of the Pyrahedron, or it's the wheat cake. So anyway, that's it from New Spirituality and George today. I hope you appreciated the video, and thank you so much for watching. Much love to all, and until next time, to whatever life unfolds and whatever creation brings you. Peace.